Okay, we are almost done. I'll write some parts of the loop manually as there will be a couple of new things we want to show you. As before, for epoch counter in range max epochs, semicolons. We start by setting the current epoch loss to 0. Next, we will create the loop which will iterate over the training data. As we explained in the lecture about the class, since the class is iterable, we can simply write for input batch, target batch in train data, semicolons. In this way, we will take input batches and target batches from the train data 100 samples at a time until we have gone through the whole training dataset. Being able to do that in such a concise fashion was more or less the purpose of the class we created. Excellent! The next piece of code is the same as before. We will run the optimization step and would obtain the mean loss by feeding inputs from the input batch and targets from the target batch. At the end of the loop, we will add the batch loss to the current epoch loss, as before. That's the whole loop. The only difference is that we used our own data provider which we created in the class lecture, instead of the MNIST data provider. Alright, next we will have to calculate the mean current epoch loss. It is equal to the current epoch loss variable divided by the number of batches. We get the number of batches from the train data object. Going back to the class, we see that there is an attribute taking care of that. Okay, that was the training part. Notice that everything is as parameterized as possible. This loop won't need to be adjusted in any way when you want to reuse it. Alright, time to validate. I'll set the validation loss and the validation accuracy for the epoch to 0. How are we going to approach the problem? Like true programmers, right? We will copy-paste our training batch code and adjust it where needed. So, what are the changes? For input batch, target batch in train data will change to validation data. Then, we want to fetch the loss and the accuracy by running the mean loss and the accuracy operations. We'll feed the inputs and the targets from the input batch and the target batch respectively. I'll record the values directly in validation loss and validation accuracy. As we said before, our data provider was created in a way that would load the validation and test dataset in a single batch, while the training data in many batches. Moreover, the optimize operation is now absent, so we will simply forward propagate the whole validation dataset through the net. You may wonder why we need a loop. We are using it since our class was an iterator. Logically, this loop will always have a single iteration. Using a loop won't affect the speed of the algorithm and is much easier to grasp because of the similarities with the training loop. Cool. Finally, I'll copy and paste everything else we had in the MNIST example. We have the statistics for each epoch, which remain unchanged. Then we have an if statement, which triggers early stopping by breaking the loop if the validation loss starts increasing. Finally, we record the current validation loss in the previous validation loss variable. That's all. Let's go over the process. We create a loop for the epochs. It iterates until we have reached the maximum number of epochs. Next, we set the current loss to 0. We train the model in batches until the data in train data is exhausted. We optimize the mean loss by feeding the algorithm with data from train data in batches. We record the sum of all batch losses. When training is completed, we will find the epoch loss by dividing the sum of the batch losses by their number. After the training comes the validation. We set the validation loss and the validation accuracy to 0. We forward propagate using the same class but with a single batch. The validation loop iterates only once. We directly record the validation loss and accuracy in the respective variables. At the end of each epoch, we print the statistics, which are formatted in an easily readable way. Finally, we check if the validation loss is increasing and trigger early stopping if needed. That's the whole code. Our next lecture is going to be an exciting one, as we will run the code we have prepared. Thanks for watching.